Okay, let's go through question 8. First of all, rate of change means dy dx or g dash of x. That's the first thing to note. The second thing to note is, well, these are all trig functions, that's not a problem. And the other thing is, this is in radians. Now you can put that in your calculator as radians, or if you like degrees, you should know that's 180 over 6, which will give me 30 degrees. Okay, right, let's start with differentiating first of all, g dash of x. Now we did some of this before. Tan, we said when you differentiate, tan goes to sec squared. So we get 1/4 sec squared x. So that one's done. Now we said that when we differentiate, cos goes to minus sine. Now minus minus will make a plus, so that becomes plus 3 sine x. So that one's done. And this is just year 12, take the power down, take 1 to the power, minus 3x squared. So we're happy how we differentiate that at all. Now, we need to find the rate of change at that point, so you need to sub in 30 degrees or put it in radians. Just put it straight in the calculator if you want. You've got to get an exact, looks like you've got to get an exact value here, to be honest with you. Now, you don't know how, if you don't know how to put this in your calculator, I'm just going to put degrees in, because I like degrees. I'm going to put it as 1 over, now that's going to be 4 cos squared. I'm going to put first 30 there and put big brackets, because all that's going to be squared. And then I'm going to say plus 3 sine 30 there.
So what's the sec over cos?
That's what it is. The sec function is 1 over cos. That's the definition that you should know. That sec x is 1 over cos x. Okay, that's what it is by definition. And that's going to be minus. Can I just apologize? Because we got this, we have to keep it in radians. Can I just apologize here? Scrap this first idea of putting it, so let me just go back. Because we got numbers in there, we have to use radians, my bad. Well, in here you have to, so you could still use degrees, sorry, on there, but I'm just going to put it all in radians. 4 cos pi over 6 all squared, plus 3 sine pi over 6. You could actually still do that in 30 degrees, that's not a problem. Just remember this one is going to 3 times pi over 6 squared. So what you end up with, I'm just going to put that in my calculator. I'm going to probably still use degrees because I know I get a nice answer from that one. So if I do cos of 30, I'll get, I'm going to get 1. I'm putting all the steps in so you can see exactly, because I think it might need an exact solution. So that's going to be root 3 over 2, which I'm going to end up squaring, and then times it by 4. I'm just putting all the steps in there for you guys. Please don't mind. If I do sine of 30, that is a half. And this one is going to be minus 3 times pi squared, and that's going to be over 36. Now I'm doing an extra step there just so that you can see exactly what's going on. That's going to be now 1 over, now when you square that, it's going to be 4 times, now root 3 squared is just 3, and 2 times 2 is 4. And those 4s are going to cancel, so I'm going to get 1 over 3 there. This one's going to be 3 over 2, and that's going to be minus, well, I'm just going to cancel 3's into there is 1, 3's into there is 12. So I'm going to end up with pi squared over 12. And now I can simplify this quite easily. Well, I'll put one more step in. That's 1/3 plus 3 over 2 minus pi squared over 12. Now, you can just simply do that on your calculator. You can just do 3 over 2, add 1/3, and you will get 11 over 6. So 11 over 6 plus, oh sorry, not plus, 11 over 6 minus pi r squared over 12. Now your book might put this all over a common denominator, which is 12. So if your book gives you the answer 22 minus pi r squared over 12, that's fine. Okay.